Let me know when everyone can see my screen. Hopefully, yes. Okay. Okay. So just a quick recap what we have covered in last day. So it's related to business intelligence. So what is business intelligence? Actually, it's the overall process for which data engineers are working. So with the data engineers, we are taking data from the source system, pushing it to target one. The past data which we are receiving from the source system, it's totally transactional data. It's not the meaningful one, but we are converting everything in a meaningful one, and pushing it to target data warehouse. And on top of that one, the visualization team or maybe some the data scientists. There may be some another data analytics teams as well. So on top of data, they can do their work so that the data can be used, and the hidden pattern of the business or anything, any decision on top of that data can easily taken. Okay. So this is called business intelligence. So nowadays, the big industry, not only big industry, even the small scale, medium, everything. They're trying to improve their business, and they're trying to get this hidden pattern. So that is called the business intelligence. Earlier, it was not there. Something they have to take manual decision. So the decision or to get the hidden pattern, I mean, uh, they need to, wait for a long time. What should be, they're doing a thing, but they're not getting the correct result. But nowadays, it's very easy on top of data that they're researching it, and they can able to find what should be causing the issue or what is good for their industry and everything. So that's why business intelligence nowadays, it's a very much important. Okay. So last day, what we have, left. We just covered fact and dimension. If you could remember, I'm just quickly starting from that point onwards quickly. So what is fact? Again, that was already been covered. Just I'm quickly going through this topic for 1 or 2 minutes. So what is fact? Fact means, if we have a collection of data, then if we can questions on top of data, how much or how many, that should be quantitative in nature. Then what particular answer we will be receiving, that should be our fact. Fact should be also called as measure because it's a quantitative value. So just like revenue, cost, number of accounts, those are called fact. The fact can be stored in fact table. In data mart table, there may be two kind of tables. One is called fact table, another one is called dimension. So the fact table should be containing those facts in red color, you can see, and the topmost thing are keys. So the keys may be the primary key for that particular table, and the other keys are foreign keys for another dimension table. On top of that keys, we can join between two tables, not two tables, multiple dimension table with a single fact table. Okay, that thing I'll be coming in the data modeling part. So I'll be coming to this point after a few slides later. So we can quickly check on that thing then. So that is called fact table. And now let me come to the dimension. What is dimension? If we just questions on top of data, who, what, when, where. So what kind of answer we will be receiving? That is called dimension. Okay. Just like customer, geography, product, time, employee, those kind of table. So if we just going to store anything on employee related table, then that should be employee dimension. There should not be any measures actually, but all the employee related information should be there. But there must be I mean, a primary key, just like employee key should be there. And in the fact table as well, there should be a foreign key so that we can join between fact table and employee table so that in time we can fetch the information between fact and employee, respective employee. So this is the concept. Just like the same thing, what I was telling that you can see that in the store or product particular dimension table, you can see The first one is primary key, store key. In the product table, there is product key, and the rest of the thing are the dimensions. Okay. So in the data modeling, I can quickly show you how we can join between fact table and multiple dimension table. Then based on these key columns, we can make SQL joins and we can fetch data. Okay. Okay. Now these are the new topic which I will going to cover. The term is very much important. The term is new to maybe if you are new, you are going to join a company or you are already working. Just I'll be requesting you for having those knowledge. That is very much important. The term especially because maybe you are owning a project or you may be a team lead or anything. You are working as a developer. So if anyone says what is, just go ahead with this particular grain. But grain is very simple. If you know the meaning of grain, then that is fine. But if you do not know what is grain, then you need to search it over there and you need to find what is grain and all. So grain, granularity, those kind of terminology is very much used in business intelligence or data engineering project. So grain, what is it? Grain is the business definition of factable row. So maybe when we are getting the applications, when we have the task to create the fact table, then they will tell us, they will maybe the product owner or maybe our team lead can tell us, create the fact table with this particular grain. So what is grain actually? We can also say that particular row of this fact table, what it signifies. So that is called grain. Let me go ahead with some example, then that should be clear. So this is a fact table. You can see in the fact table, what is the grain? A particular row is signify. What particular thing a particular row is signifies. So we can say that it's a sales transaction per item in a bill. It's a bill. So per item, what is the sales transaction? Sales transaction means we need to have what is the quantity for that sale and what is the amount the particular sale occurred. Okay, this kind of stuff. Let me go to the next one. Just like this is a exam result, we can say. So here the grain is marks of a student got in a subject in an exam. Okay. So actually for this Aryan Dev, we can see it's, if I say only marks of a student, then it's not clear because one particular row, you can say the grain, we have that particular detailing for subject wise marks for Aryan. That's why marks of a student for a particular subject in an exam. You can say also exam is defined over here. Finals, media, finals, this kind of stuff. So a particular row is signifying this stuffs. Okay. It is also depending if I do not say the subject, then you can use the group by clause over there. If we could remember, we can omit the subject over here. Irrespective of that, we can just have for final what is Aryan Dev's total number. We can put the same thing. Then the grade should be different for this fact table. Hopefully, I'm able to convey the message. So grouping the thing, group by or any kind of aggregation, what we have learned in the Python as well, in SQL as well. On top of that, we can change the grain of a particular fact table. Okay, so whatever is required, what particular granularity level the particular data team or the visualization team wants the data, we need to prepare in that way the fact tables data. Okay, so yeah, that is called granularity. The next topic, how much line items we can provide, how much detailing we can go ahead in fact tables data. Okay, so that is called granularity. Maybe users want to see for a final for physics for each section wise marks. Okay, that should be more granular. There may be another column over there, just like called section. So for exam final, there may be 3 section or 4 section. Section 1, section 2, section 3. Section 1 should be multiple choice question, 2 is short question, 3 is broad question. So just to analyze a particular student's drawbacks or what should be his plus point on top of which particular section he need to work more to get greater performance in the next examination. So we can split it in section wise as well. So it totally depends on our product owner or our visualization team, what kind of data they require. Okay, so that is our, we need to know what is our business motto. On top of that, we can split it. So that is called granular. How much granularity, how much line item. If the particular data is more granular, then we need to introduce more line items. We need to segregate that particular data into individual section. Again, we can put individual question number as well. That should be another level of granularity. So that is called granularity. Low granularity refers to the data is summarized or aggregated. Low granularity means we can aggregate the data using group by function, and then we can show it. High level of granularity, that is called also atomic level. The more deeper we can go inside the data, that is called atomic level data. Okay, high granularity refers the data is at the near transaction level. So what particular transaction is happening? So that is the lower level. Sorry, the high level. Okay, hopefully that is clear. If not, please ask me. Okay, hopefully that is clear.
Yes.
Okay, thanks. Totally, actually, I'm just going to say it's the particular technical part kind of stuff we have already covered, but those are useful, very much useful actually, for kind of your knowledge setup or maybe your interview questions. They can ask this kind of stuffs. This is very important stuffs. SCD, that is called slowly changing dimension. So there are multiple types, type 1, type 2, type 3 actually we are going to use over there in our project. So what are those actually? In our project, they can say build the dimension in SVD type 1 or type 2, this kind of stuffs. So how to build this thing? I have an Excel prepared for that one. Let me check. No, I have saved it for another way. Let me create another example over here. Okay, so what is SVD type 1? This is an example I'm just going to share. So, for fact table, we just go ahead with some examples. For dimension, this is a very much important example how we are storing the data at the dimension table. Okay, so dimension, maybe let me create employee dimension. So over there, it's a employee dimension, employee table. What kind of data should be there? Employee ID. This should be the primary key. Employee name, or let me put employee designation. Okay, let me put these three columns over there. One, let me put employee, suppose A, B, C, his designation. Uh, Let me put trainee. Okay, he just joined the company. That's why I'm putting trainee. Two, B, C, D. It's account manager. Okay. Senior developer. Okay. So the particular data can be modified slowly, but it can be daily basis or it can be monthly basis, yearly basis. Okay, based on how much transaction is occurring. Especially we can say dimension table refresh. The change in dimension table is very less frequent. It's less frequent comparatively to fact data. Just like employee table, we are containing all the employee information in a particular table. Suppose we are just going ahead in the organization, a sales organization. We can say it's a shopping mall or just like this. We can say that in a particular day basis, we cannot change the employee table, but the fact table is changing per second, in per second, but the employee table cannot change per daily basis. So, especially, I want to convey that the dimension is it's not too much frequent that the data is getting updated. Suppose we have a country table where we are pushing all the country name with the ID, and I think we have something 280 number of countries there, but the country is fixed maybe 1 month, 2 months. We do not need to change anything. So maybe someday a country has been introduced, then only that particular thing can be refreshed. So that's why dimension itself is a slow changing, but fact is, I mean, transactional level of data can be stored in fact. That's why it's changing very fast. The data is pushing, I mean, getting pushed there very frequently, maybe per second, maybe per hour, or just like this. Okay. So based on projects, this is depends. But I'm talking to dimension currently. So for slowly changing dimension, just like this, the data got refreshed today, and tomorrow the particular employee is having his year of anniversary, and his 1 year of probation has been completed. So tomorrow when the data got refreshed from the source side, then that can be updated to developer. He was trainee, developer trainee. Now he becomes developer. Okay. So this kind of information is getting stored in SCD type 1. So why it's type 1? Actually, three kinds of difference are there. That's why we, based on that difference, we are putting this in type 1, type 2, type 3. The type 1, we cannot check the historical information. So you cannot check when the particular employee has been, their designation has been modified. So this kind of information we cannot check from type 1. So that's why type 2 has been introduced, where we can use the historical information as well. Just like we need to introduce another date over here. Okay. So which date the particular changes has been occurred, which day he has joined, that should be trainee, which particular date BCD has been promoted to account manager, that should be stored over here. Okay. Suppose it's 23rd Jan, that should be something 24th June. I should be also putting the year. Mm, just like this. So very next day we can see, actually for the trainee period, we have only 1 year trainee period for the particular company. So when the next day comes, another new row should be implemented over here. Okay. Let me add the thing. Let me down this thing over here. Then employee ID is not a primary key over here as well. Something we need to go ahead with some composite key. This table, I need to introduce ABC again with permanent developer. So today is 24th over here. Some 24th Jan 2023. So I mean to say this thing. So I have the information of ABC, which particular designation he or she was having. Okay. And again, we have the new one, new row, which has been reflected. I will be storing both of the information, but those are not duplicated because we have a date column, which will be showing us the particular transition date, which particular date that particular transition happened. Okay. That kind of database storing in dimension is called SCD type 2. We should be maintaining the history information as well. Based if the particular product owner they needs the history information, they need to check which particular date the promotion has been occurred. Then this is a very important steps we need to follow. Then employee ID should not be the primary key. We can see this is duplicated over here. We need to took something more, just like employee ID and employee designation. So on combination of these two columns, it should be a composite key for this table, because same employee ID, same designation should not be there. The designation has been modified. That's why we are having a new row over here. Okay. So employee ID and employee designation would be a composite key in that case. Just I'm giving the example. In particular project, you can see lots of examples or your practical scenarios over there. But these are the small examples. So I just mean to say we should be having historical information stored over here in type 2 in this manner. Okay. Now, what should be in case of type 3? Any doubt from anyone till now?
Yes.
You have doubt or you get it actually? I was asking
Yeah,
for
okay,
any.
no problem. Yeah.
Okay. Okay, fine. Thanks. So what should be type 3? I mean, type 3 actually. Even as per my knowledge, we used to create this kind of stuffs in industry. Type 2 or type 3 generally. Type 1 we generally do not do. In some dimension we can go ahead, just like country dimension. What is totally slow one? So that thing is getting stored, maybe I mean changing yearly basis or 2 years. It's having a change. So that kind of dimension table, we can get the information from the owner that we can go ahead with SC type 1 only. We do not have to store the historical information. But over here, based on the dimension and our what is our perspective, based on that thing, we can quickly modify or update what should be the type. So for type 3, if we are having this kind of data, type 3 is also loading the historical information, but it's not increasing its row. Okay. It's increasing another column over here, just like this one. Previous designation. It's also not storing all kind of historical, just like it's storing the previous one and the current one and the latest transition date. So it's putting this thing, developer over here and trainee should be over here. So this is type 3 information, type 3 visualization of a particular dimension. I did not store those there's previous designation that should be also there. So I just focused only on top of this row, what should be the data. But if we are going to design this kind of stuffs, we have to implement everything. I mean, for every row, we need to work on that thing. Okay. So this is called type 3 data visualization. Okay, SCD type 3. I'm going to the slide again. Hopefully that is understandable. Okay. So what is the next topic? It's called data modeling. As I was telling that time, that fact table is having not only the fact rows, fact data, there must be having some key columns as well. So that's why why key columns are required over here. The central one is a fact table. This thing are dimension, you can say, is a time dimension, is a store dimension. We should be having all store related information. Is a Clark dimension. All the Clark related stuff should be stored over here. Those are called promo. Promo dimension. What kind of promotion we are going ahead? We are doing and everything. You can store the thing over here. Product dimension. All the product related information should be there. Customer dimension, register dimension. So everything should be there. From the source system itself, we are receiving the raw data, which is not meaningful one. But when we are storing everything in data mart, then we are segregating the thing in fact and dimension. Then after that, we are creating the data modeling so that we can join which particular record is required. We can join between fact and those multiple dimensions, and we can fetch the data easily. Okay, so this is the entire concept. For the data modeling, starting from loading the data from source system and pushing it to data mart tables, which column should be there for each fact and dimension, that should be correct. And at the last, at the end, we need to create this kind of data modeling. This is very much important. Even not only this, we need to set the cardinality as well. Cardinality means for the time key and this time key, what should be, it should be 1 to 1 or many to 1. And for particular fact table time key, how many time key should be there in this dimension. So this kind of cardinality we have to set. Based on that, we should have to go ahead whether it should be inner join or right outer join or left join. Basically, fact should be calling first. It should be at the left table. If there is one-to-one relationship, we can directly go ahead with inner join. If this is one to many, then we can go ahead left join. Fact should be the best table. It should be in the left side. And based on which cardinality we will be having this dimensional modeling or data modeling, the dimensions are join over here. So, on top of that one, we can choose what kind of join we need to perform while fetching the data. So this is the entire purpose for the data engineers. We can just also see that in the fact table, time key is a foreign key, and in the time table, time key is the primary key. So we can join this way. Same way, just like product key, customer key, you can see over here, customer key. So we need to build in this way properly, in proper logic while creating those data marts. The fact table should be having all the foreign keys as well as the primary key of that table. Dimension table should be having all the primary keys for that dimension, and let's join together. So this is the concept. Data modeling is very much important thing, and this should be crucial. Otherwise, when we will be fetching the data by maybe data visualization or maybe by uh, any data scientist, if we do not store the information properly, then we can get the duplicate data as well. You can face the duplicate data. That should not be the correct one. Okay. Give me 1 second. Okay. So this is very much important, the dimension modeling. Okay. Now you can get the questions in interview. You are going to face an interview, then you can get this kind of questions. What is data modeling? What kind of data models you have worked on or you will be working, or in your experience, what kind of data models you are aware of? You can say star schema, star and snowflake. Those are two kind of main data modeling part. So what is star? Star, as per, let me show you a scenario. Yeah. Star, maybe there should be a single centralized star table and all the dimensions should be just like this way. The example that I also provided you earlier. So fact table should be the centralized one and table should be surrounding it. Just like this example, sales table is there. So it's a fact table. The store, time, customer, product, payment type. Those kind of stuffs are called dimension. Okay, you can see in this example as well. So if we are going ahead with this kind of data modeling, that is called star schema. Okay. So what is another example that is called snowflake? So snowflake fact table should be centralized one, but you can see just like in a product dimension is there, geography dimension is there, time, organization, customer dimension is there, but over there brand dimension it's not joining with this fact table, rather it's joining with the product. So over there we can say product is not a normalized table. If we already know what is normalized table, I mean, in the product, we are splitting the thing again into brand. Then in brand, we are splitting it again to category. Okay. So this is called Snowflake schema. We are not, I mean, in the dimension table, we are not uh, segregating it at the lower level so that we have a key, common key with fact table and dimension table. We are going at with this way so that we have the relation between dimensions. Over there in star schema, there is no particular relation between two dimensions. All the dimensions are independent to each other. They are directly joining. They are depending with fact table only. No internal dependency between dimensions. But over here, some dimensions we can see. We for going ahead with more granular level for which brand or anything, then we can go ahead with this structure. So based on which kind of project we are facing, we need to take this decision. Okay. This is very much important. Actually, in practical purpose, we mainly use Snowflake schema, but there is some drawbacks for using Snowflake. There is some advantages as well. Just like some particular schema stores less data, but not complexity. I mean, to handle more complex things, we can use Snowflake. Snowflake also takes, I mean, lots of spaces as well. But if there is small project, easy to handle, then we can go ahead with star schema. But if this is a complex one, then that cannot be handled by star schema because for fact table, each of the particular dimension we need to create each of the key. That is not an easy task over here. Okay, so that's why we need to be cautious on that topic. Which particular, data modeling schema we need to get into our project. Okay. Okay, now I will be just going ahead with some ETL concept. What is ETL? ETS means extract. ETL means extract, transform, load. Okay, so from source system, we are getting the data. E for it, I mean extract, T for transform, L for load. E for extract, I mean extracting the data from the source system. Then we are transforming the data. So what kind of transform is required? So maybe we need to clean the data first. There may be some white spaces with each of the records. Maybe the records are not good. Each of the records, maybe something is in caps, something is in lower cases, but we need to go ahead with single font. A date field, maybe we have a date field, it's not a proper date. So we need to convert the thing in date format. So this kind of conversion and cleansing thing, we can go ahead with transformation logic. In transformation as well, maybe we need to sort the data in proper way. Maybe we need to have have some aggregation function as well on top of that thing. We can have some concatenation function or just like this, several kind of transformation. We need to go ahead with a particular data loading part. So the particular transforming part is done by transformation T. Then the last point is load. It's loading the data, the target database, where we are creating the data warehouse and data marts. So that is the concept of ETL. So I'm just repeating again, ETL is required for loading the data from source system to our target. Target means where we are creating the data warehouse and data mart. After loading the data at the target data warehouse, then we can create those fact and dimensions. So before creating the fact and dimensions, this is the earlier steps. We are loading the data from source to target, and those are the kind of flowchart and what kind of thing we can obtain from this system. Okay, so there are various kind of ETL tools are available to load the data from one system to another system. I'll be going through this thing, but there are some quick logic or quick convention how we can extract the data and load the data. Okay, that concept is very much important as well. So data extracting method, how we can refresh the data. So we have particular batch job or batch script available when the data is getting loaded. Because we have the table, we have the data warehouse, we are having the data mart table, but I mean, yes, till yesterday we have load something data, load some data over there. But in the very next day, we should be having new data in our source system, in our source transactional system. So that particular new data should be captured in our data warehouse as well. So this kind of extracting methodology we need to follow. That can be full refresh, that can be incremental. So what is full refresh? So daily basis, which kind of data is coming? We are not checking that thing. We are not checking which are the new records. Irrespective of that, we can just truncate our destination record. I mean, maybe in the source system we have an employee table. At the target as well, we are storing the same thing in a different database, but the table is same employee. Okay. So if we are just going ahead with full refresh, what should we have to do? We need to truncate. Truncate means deletes all the records at the target system, and we need to check what are the total records at the source system. We can push everything in the target. So that is called full refresh. What are the records over there at the source system? We can directly push all the thing at the target side. So that is called full refresh. And what is incremental? So maybe we have, I mean, millions of records. So daily basis, or maybe if the days goes, we should be having more transaction. So today we have 30,000. Tomorrow we have 50,000. After 1 month, it should be 1 million. So this kind of data should be growing. But why should we push all these records in a single instance? Because that will take more than 1 hour, 2 hour, 3 hour, or this kind of time for data refreshing. So we cannot do that particular thing. Then we can go ahead with incremental load. We need to check what particular new records comes to the table in the day's interval. Maybe we have last load the data in 5 p.m. EST timing yesterday. So we need to check what are the new records come after 5 p.m. EST. So we can only load that particular stuffs in our target. That is called incremental. Okay. So based on which kind of data we are storing, or what is the frequency of the source table is getting refreshed. On top of that one, the architect, data architect, or any other the project admin or project owner, they can define what kind of data extracting should be there from the source system. Hopefully I'm understandable. If not, please tell me. Okay. So what is data loading? The same way, if we are just go ahead with full extracting method, then we have to truncate the table and load the table. Okay. So if the table is, I mean, incremental load, then we can go ahead only insert load. We will not be truncating the data. Which are the new records? Will be just inserting that records only. Okay. There is another one, update and insert. Suppose we are going ahead with SCD type 1. Okay. Over there, we are not maintaining the history one. Rather, we can say that particular record has been updated. Okay. Let me quickly show you one stuffs. For SCD type 1, let me delete that thing, or let me hide that thing. So for SCD type 1, till yesterday we are having these records. And today, from the source system, we can see the source system records has been updated. This one, trainee to developer. Then the insert thing will not occur. It will not properly working. Then we have to go ahead with update and insert logic. So in our system, they will check on based on the primary key if there is any particular data has been updated on based on primary key, obviously. So they will see that particular employee ID 1, it has been updated from trainee to developer. Then they will update the data. Okay. So in the very next day, they will check one new record has been updated. Someone has joined as the trainee as well. Okay. So they have to go ahead with update and insert. That is also called upsert. So they will update the existing records if there is any update. And if there is any new record, they will check if this is a new primary key, then they will insert the record. So that kind of loading methodology is called update insert. It's also in short form, it was called upsert. Okay. So it's very much important. Upsert logic. What is upsert logic? They will check on based on a primary key. If a particular record has been updated, then they will update the same thing at the target side. If this is a totally new primary key, then they will insert it. The comparison should be with us. They will be checking with the history table or what is the table at the earlier side. They will be comparing the thing. If this is a new primary key, they will directly insert. If this is the primary key is already existed, they will check the data. If the data there is any mismatches, they will update it. So this is the upsert logic. Okay. ETL tool. I mean, we are doing some. I mean, this kind of ETL operation, this kind of loading operation by some tool, or maybe there is some open source coding stuffs. So let me go ahead with next slide. Yeah. So those are all ETL tools. You can have anyone experience of anyone or maybe one certification if you are already having or maybe you are already working. So just like there are Informatica, there are IBM. I mean Informatica is a product vendor, and this kind of ETL tool we are using. It is called Power Center. In IBM we are having Data Stage, Ab Initio. For SAP there is Business Objects Data Integrator. There is a tool called Cognos, Cognos Decision Stream. In Microsoft, there is SQL Server Data Transformation Services. Oracle, there is Oracle Warehouse Builders, SAS ETL Studio. So this kind of ETL thing is also there. I also had Talent. Talent is a ETL tool, Talent Studio. So there is lots of ETL tools are available for connecting various data source system and to go ahead with this data loading strategy. Okay. So in each of the, I mean, there maybe have some licensing cost of that one. Which kind of ETL tool you will be using? There is some cost related to that one. So, but it's totally dependent on which, I mean, your architecture and the product owner based on the economic condition or based on how much volume data daily basis you will be transact. I mean, your transaction should be there, or and also your company policy. So in your company, they only allow only this kind of ETL tool. So based on this thing, they need to acquire which kind of ETL tool they can work on. And nowadays onwards, I mean, most of the project they are not using any ETL tools. Rather, they are using open source coding system, just like Python, Java, JavaScript. So they are creating a framework, just like it's totally working as a ETL tool only, and the developers are doing some metadata information insertion at their side. Metadata is being stored just like source table name. They're taking which kind of logic they will be picking data, select star from the source table, maybe some columns, maybe imposing some joining condition. They're pushing the data. This kind of metadata information they need to push somewhere in the framework, and they're picking the data and which kind of transformation they wants to go ahead with. They need to put the same thing in a template or in the framework somewhere. They need to put that kind of stuffs as well. So those kind of um, frameworks are also being used as a ETL tool. It's not a direct ETL tool, but Python is working that time as a ETL tool. So that's why we learned Python. If any kind of framework is working, then we can also go ahead with that help. Okay. Okay. Let's see what are the next topic. Yeah. Now what we have learned till now. So we have loaded the data from source system to data warehouse with help of ETL. Then we can build fact table and dimension table and store those kind of stuffs in data mart. Now what the visualization team will do? They will be calling those tables, fact table and dimension table. They will be creating a data modeling, and they will prepare the charts, graphs, and all so that the business owner can take the easy decision by checking those graphs. So while creating those graphs, they need to, I mean, check which kind of KPI. KPI is called key performance indicators. Suppose I mean, the visualization team do not have the authority to create any kind of graphs and charts. So that is totally depends on the product owner, which kind of motto they want to satisfy by checking the graph. You have created one graph based on two dimensions, one measures, or just like this. But the product owner will say that this is meaningless. They do not require that one, or that particular kind of thing is not in any help of our business. So that's why the KPI is a thing. KPI is, I mean, user need to say that we need this information, just like growth in last 5 years. So this is called a KPI. So KPI is a single, I mean, it's a statement or single phrase where just like the fact grain, what we have told for a particular grain is one particular row is signifying what kind of stuffs. The same thing is for KPI, which kind of chart or graphs that kind of thing will signify. So this will, I mean, that is called KPI. Okay, we have some examples. Okay, and that's like KPI. What is KPI? Just like it's a critical metrics for measuring and performance for the business. It should be oriented on company strategic and operation goals. It should be also helping with visualizing performance. That is correct. So this kind of stuffs. But what is KPI actually? Just like this one. User want to see sales growth or quarterly revenue. So this is called KPI, key performance indicator. So you need to create such a graph that you should be, suppose you are having a line chart having year in x-axis or quarters should be in x-axis and in y-axis revenue. Okay. So then that will satisfy your quarterly revenue graph or quarterly revenue KPI, you can say. So KPI should be in generally two types. One is called quantitative and another one is qualitative. Just like customer satisfaction, product quality, those are called qualitative. And quantitative also, some numerical value should be there. Okay. But KPI is nothing less. I mean, just like they need to tell what kind of KPI they need to check at the dashboard side, and then the visualization team will create those kind of graphs and charts so that they can check it properly at their side. Okay. Okay. So I just give you an example over here. So the visualization team can create this kind of graphs and charts. This is a bar diagram, bar graphs. Over there we can see uh, there is zone versus revenue. In each of the zone, there are two dimensions. One is called ER, another one is called zone. You can see in x-axis the dimensions are put, in y-axis the facts are put. In x-axis zone is there, east, north. There are four zones. Each of the zones it's also splitted into ER dimension. So two dimensions are noted over here at the x-axis, and in y-axis one particular measures are there. In checking the graph, it's easily visible. The KPI can be shown easily to the product owner and they can take easy decision. Okay. There is some more thing, pivot table. Pivot we have already discussed in our last time in maybe in Python or any other. Yeah, Python we have showed pivot. So pivot table is nothing but we are transposing the thing. Over there in first example, we can see in x-axis, I mean, sorry, in this chart over there, we have the years and those are by various cities. Can just remove that thing. But it's totally dependent on how much complex we can go ahead with pivot. There may be multiple thing in columns. Okay. Or multiple things in rows as well. Okay. Multiple dimensions we can say. So based on how the users want to see the data, we have to go ahead with proper, I mean, designing the proper pivot table in that manner. Okay. Okay. So irrespective of pivot, we can have slice and dice keyword. So what is slice? Oh, okay, we can see this particular graph over there as well. In a x-axis, we can see various dimensions are there, just like city and ER. Okay, it's not only x-axis. We can say it's if we have x, y, and z. In x and y, we are maintaining dimensions, and in z-axis, we are having uh, quantitative thing that is measures. So x-axis it's city, in y-axis those are years. This is a 3D graph. over there, if we are going to slice it, so slice based on an year. So in the visualization as well, there may be some filtering operation. So just like where condition in SQL side. So over there, we are slicing the graph or slicing the visualization thing on top of a particular single year. Then only the blue color thing will be picked up. Just like we are choosing some filter or drop down filter on top of this visualization, that is year equal 2009. Then we are slicing the thing. Okay, that is called slice. So the thing should be just like this. Your product owner can say you, so create such a graph, 3D graph or just like this, so that I can slice and dice. I can slice on top of here. Then you need to create this kind of graphs. Actually, this is a chart, is a 3D bar chart. So you need to go ahead with choosing which kind of chart or graphs you need to choose on top of your data. This is dice. So dice, we can take two things at a time in the filtering condition. Just like we have chosen city as well as year, but both of them you can see we have eliminated some city. So in city as well we have put some filter, as well as in year we have put some filter. That is called slice and dice. Slice on top of only one dimension we can check. Dice we can check multiple dimensions as well. Okay. Okay. There is another thing. What is roll up and drill down? Those are all while creating the visualization graphs and charts, or maybe while creating the KPI, they will say you create this kind of stuffs. So roll up means, suppose in this chart or this particular bar, you can see it's year and city wise yearly sales. Okay, we can create the year such a way, then we can create the year in hierarchical manner. That should be your internal code. You need to create the year in this way. You can see when we are drilling it down, we are drilling it down. The second chart you can see when we are drilling it, we suppose we click on 2013, there should be a hyperlink. Then only 2013 quarter should be available over there. So we are drilling it down. The same thing should be appear over here. Then again on quarter one, on quarter three, we are clicking it over there, and it should be showing it monthly wise drill down. Okay, the same thing should be there in the bar as well. Okay, so that is called drill down, and the same the particular vice versa thing. If we are just going from the last graph to upper thing, that is called roll up. Okay, so you need to, that is totally dependent on your design. There is some charts available for drill down, as well as you need to create the dimension such a way in your dimension table. Maybe there are time dimension or date dimension where you need to uh, do the proper mapping such a way that year, quarter, month should be aligned over there. Then you need to create the hierarchical dimension, and you need to pick this dimension over here. Then only that drill down should be working. Okay. So that is, deeper thing when you are just, if you are working as a visualization team on top of data, suppose you are working in Tableau, in ClickSense, then this kind of stuffs is very much helpful with you. Okay, I'm just going ahead with the terminology so that there would not be any issue when you are working in any of the company. So those are the all stuffs for business intelligence that I covered. So those are, not high level, some deeper level as well we have gone through. But if you are going with hands-on experience on any tool or just like this, then that should be most helpful. But the terminology is same. You can check the same thing in Google if you just want to get some more perspective on top of that one. But uh, maybe when you are onboarding in a project, then you can have this hands-on, just like drilling up, drill down, this kind of stuff. Okay. So any doubt till now? Okay, hopefully no. So let's connect tomorrow. Business intelligence we have covered. Uh, we will be covering the other part